Now on this we will see that using reduction formula how we can do problems which can be asked in section B or section C. Now first we have this problem, evaluate integral 0 to pi x sin x power 5 dx. Now if you don't have x, then you can make use of this property of definite integral and you can evaluate, but x comes, so for which we have to make use of this property also. So you have integral 0 to pi x sin x power 5 dx, name that as I and that equation as 1. You can rewrite this as this also, making use of this, and we notice that sine of pi minus x, we notice that sine of pi minus x is sine x only, whereas cos of pi minus x, it is not given here, but notice this, cos of pi minus x is minus cos x. But on the other hand, if you have the power to be say even number, then in that case you will get back that even number, means you will get back the same. Cos pi minus x power 4 means cos x power 4. So it is cos of pi minus x only minus cos x, but when you have the power to be an even number, then there will not be any problem. Okay, so here we don't have cos, so only sine we have. So we make use of this property and we get this step. So we add these two these two equations. If we name this as 2, then this x will get cancelled. The term with the x will get cancelled. So you have just pi sin x power 5 dx. Pi is taken out, so you have this. And reduction formula for integral 0 to pi sin x power 5 cannot be used. So it should be of the form 0 to pi by 2. So what we do is we rewrite this pi as 2 into pi by 2. So when you have, so in this case my 2a stands for pi. In this case my 2a stands for pi. So only if you have, we have seen this property already, if this net is there, this hero will jump down, nothing will happen. So f of 2a minus x means in this case f of pi minus x. So you have sin x power 5 dx. When you replace sin x by, x by pi minus x, it is retained. So we can make use of this. So this hero comes down. So 2 into, already pi is there, integral 0 to pi by 2 sin x power 5 dx. This can be further simplified. 5, 4, 3, 2. 2 by 3 comes, so 1. And this is 8 into 2, so 16 pi divided by 15. Something similar to this, you have the next one. You have, suppose I have say sin x power, say some 5 cos x power 4 dx, x belong with x. Then in this case, how are we going to evaluate this? Again x comes, so to avoid that we have to make use of this property. So when you make use of that property, you have x sin x power 5 cos x power 4. So in the previous case we had only sine, in this case we have cosine also. So we have cos of pi minus x to be minus cos x only, but we have this raised to the power 4, so that means you will get back. So in that case nothing happens, so we can make use of this. So you have I to be integral 0 to pi minus x sin x power 5 cos x power 4 dx. Now if we add the 2, if we name this as 1 and this as 2, by adding the 2 we can avoid this x, so that integral 0 to pi, this pi we can of course write sin x power 5 cos x power 4 dx. Now again we cannot make use of reduction formula because it is 0 to pi. So we have this to be, as in the previous case, we can rewrite this pi as 2 into pi by 2. 2 into pi by 2. So integral 0 to pi by 2 sin x power 5 cos x power 4 dx. Now we know how to rewrite this, even how to evaluate this. So you'll have to add these two, put it in the denominator, and whichever is lesser in number, the index, you can start reducing it by first one. So you have 3, then 3 minus 2, you have 1, and this one 7. You cannot further reduce it, so you have to write I suffix. This you have not reduced, so retain as such. This only you have reduced, that happens to be even. So I5 0. So in this case we have, of course this can be cancelled. So you have 2 pi by 7 into, this is 5, 4, 3, 2. 2 by 3 in 2 by 3 means just 1 you'll have to have finally. So you cannot cancel anything with in the denominator. So 16 pi by 105. So you have the 2i is only this. So your I, you have 2i to be this. So your I will be 8 pi by 105. Even in the previous case, we should not forget that. So even in this case, 2i is only 16 pi by 15. Therefore, I is 8 pi by 15. So that should not be forgotten. Now the next one. So in this case, we are not given directly we cannot directly make use of reduction formula, but by giving substitution, like if we take x to be sine theta, then dx will be cos theta d theta, and the limits when we consider, if x takes the value 0, what will be my theta? When x is 0, sine theta 0 means sine inverse 0 is 0, and x is 1. When x is 1, we have for what value of theta? Your sine theta is 1. So it is pi by 2. So between 0 and 1 now becomes between 0 and pi by 2. So this becomes integral 0 to pi by 2. X is taken as this. So sine theta power 5. Dx is cos theta d theta. And you have this square root of 1 minus x square, which is square root of 1 minus sine square theta. So we have the denominator to be 2 into cos theta. Cancel out this cos theta. Taking this half out, integral 0 to pi by 2 sine theta power 5 d theta. Now for this reduction formula can be used. So half this one 5, 4, 3, 2. 2 by 3 comes, so you have 1. You can cancel 1, 2, so that you will have 4 by 15. So we have, so in this case, we are making use of this trigonometric substitution, and then only we can make use of reduction formula. Again, something similar to that. In this case, a is there. The previous case 1 was there, so here a is there. So we'll have to have x to be, say, let x be a cos theta. Okay, or a sin theta will be better to avoid negative sign. So you can have x to be a sin theta. So dx will be a cos theta d theta. So a square minus x square will be a square minus a square sine square theta, and that will be under the radical sign, means you will have a into root of 1 minus sine square theta, that will be a cos theta. Again, as for limits are concerned, when x takes the value 0, theta takes the value 0. When x takes the value a, theta will take the value. You will have a is equal to a sine theta. You can cancel out a. So you have sine theta to be equal to 1. For what value of theta? Sine theta is 1. So it is pi by 2. So you have integral 0 to pi by 2. Replace your x by a sine theta. So a sine theta the whole square, a square minus x square. You have this to the power 3 by 2. So we can write this as a square minus x square, a square minus x square. We have it as a square cos square theta, and then this under the radical sign. So what we have is a square cos square theta into a cos theta, and then for dx again a cos theta. So let me put this as a cos theta the whole square d theta. So that here we will have from this one a cube, from here one a, so a power 6. So a square, a square, a square, a power 6, 0 to pi by 2. And this one gives me sine square theta, and this one gives me cos theta power 4 d theta. Now we can make use of reduction formula so that you have 6, add the 2, put it in the denominator. You can reduce the power of the lesser one. So 1, further you cannot reduce. So you have reduced this power only. So ultimate integral E1, so 0, and I 0, 4. So it is a power 6 by 6, 4, 3, 2, 1. So half comes, and therefore you will have pi by 2. So we can cancel 1, 3, so that we have 16 into 2, 32. So pi a power 6 divided by 32. So this is what we have as the answer for this. And the next one. Here we are asked to evaluate integral minus pi by 2 to pi by 2. So you'll have to read the question carefully. The limits are between what and what, and then what you have in the integrand. This is my integrand. So we will consider this integral minus pi by 2 to pi by 2. We will expand this out. Cos cube theta 1 plus sine square theta plus 2 sine theta d theta. Again further, minus pi by 2 to pi by 2 cos cube theta, we will split and write cos cube theta d theta plus integral minus pi by 2 to pi by 2 cos cube theta sine square theta d theta, then split again minus pi by 2 to pi by 2, 2 into sine theta cos cube theta d theta. Now cosine is an even function, whether you have in the index 3, 4, 5, I mean whether it is odd or even, doesn't matter. Cosine itself is an even function. So by the properties of definite integral minus a to a, we know that minus a to a f of x dx can be rewritten as twice integral 0 to a f of x dx when f of x is even. When f is an even function, that is f of x is equal to f of minus x, f is even, then in that case we can write this as this. So it is even function, so we can have integral 0 to pi by 2 cos cube theta d theta. And coming to this cosine even function, sine is odd function only, but here in the index you have even number, so it is again even. So twice integral 0 to pi by 2 cos cube theta sine square theta d theta. But now coming to this one, this is even, this is odd. So when we combine both, we will get only odd. So when we have to be odd, then in that case minus a to a f of x dx is 0, we know already. So that means this will not be there. So plus 0. And this you know how to evaluate. 2 into, so in the denominator we have 3, 2 by 3. Then 2 by 3 comes, so 1. Plus, coming to this, you have, you'll have to add these two, put it in the denominator. You can reduce the power of this. So 1, you cannot further reduce it. So I suffix, you have reduced this one. So here you have reduced. See, even though you have cos and sine, our method is sine square theta, cos cube theta. We can rewrite in this way. You have reduced the power of this, which is even. So I0 3 is what we have. So it is 4 by 3 plus you have 2 by 5. This, when you simplify 3, 2 by 3 comes, so you have 1. So that means you have 4 by 3 plus 4 by 15. So you have 4 by 3, when we take out, you have 1 plus 1 by 5. So that can be further simplified. So 5 plus 1, 6 by 5. So 24 by 15. Or further you can cancel 1 3 and write it as 8 by 5. So this is how we evaluate on this one. Okay, then coming to the last one, you have integral, you have to evaluate this integral 0 to 4 x cube into square root of 4x minus x square dx. So what we have done here is, here had it been just 4 minus x square, we would have taken x as 2 sine theta. But here 4x minus x square. So that means we are going to take our x as, you can have it as 4 sine square theta, so that you will have 16 here and squaring that. So only for that purpose it is taken as 4 sine square theta. Right. So taking x as 4 sine square theta, this one will now reduce to 4 root of 4x minus x square. It is 16 sine square theta. And then you are squaring this. So 16 sine theta power 4 you have. Then 1 4 sine square theta can be taken out, or rather 16 sine square theta can be taken out, so that you will have 4 sine theta. You'll be left with 1 minus sine square theta, and that is cos theta. So what you have in the radical sign, that is 4 sine theta cos theta. Now dx is taken as this, so dx should be, when you differentiate, you get 8 sine theta, and then this must be differentiated, so cos theta d theta. Now as for limits are concerned, when the variable of integration here is x, the limit for x when it is 0, theta is 0. When x is 4, you will have you have like this. So 4 equal to 4 into sine square theta. This is what we have. We can cancel this, so that sine square theta you have as 1. You have, of course, sine theta to be plus or minus 1, but in this case 0 to 4 that we consider, so we consider only integral 0 to pi by 2. So you have this. Now x is replaced by 4 sine square theta. So sine theta power 6 you have, 4 cubed you have, so you have 64 here. And then this one already simplified, 4 sine theta cos theta, and here 1 sine theta cos theta is there, 8 is taken out, so this 4 is written as such, sine theta cos theta. From here 1 more sine theta cos theta, so that is written as sine square cos square theta d theta. Now we take the constants out, so that 32 into 64 you have, integral 0 to pi by 2 sine theta power 6, and here 2, so 8 cos square theta d theta. Then you add these two and then put it in the denominator. So you have, you cannot further simplify this, so I suffix, you have reduced this power only, so I 8 0, and when you simplify this, you have 8 7 6 5 4 3 2 1 half comes, so pi by 2. And then cancel out terms, and ultimately you will arrive at 28 pi. So these problems, when you have in terms of x, means substitute and then bring it to the reduction formula category, and then you can easily make use of that. So these are the problems. One is with the x just comes, then again make use of the properties of definite integrals, and then proceed. So These are a few problems which involve sine, cosine alone. We have not dealt here with tan and all. So that's not in the syllabus, so we have not covered it. Okay.